That's good.
All right, so I will record this, and let's see here. I think what I'll do is I'll pin my, there we go. So you'll see the big screen all the time.
Great.
Welcome. So what we'll do today is try to go through the equipment that I'll be sending to Ann and Mike for transfer to Spain. You can see, let me switch over to the other camera here. So we'll be doing the demonstrations on the table, but in the background, you can see the two suitcases that I'll have everything packed in. And I've got a bunch of green foam from Joann's Fabrics that does a good job of insulating things from shock. So what you'll get is the option to use either a 2-inch mini telescope that's made from, so I'm going to move this, light around so that it actually shines on the objects that we're looking at. All right. So this is the, the famous mini that was invented by Scott Degenhart some years ago. It's half of a set of binoculars attached to, in this case, a 3D printed tube from John Moore in Oklahoma. And in this case, we've got a Runcam Astro camera inserted into it, which has in it the 12mm to C-mount adapter, then a C-mount to 1.25" adapter, and then the 0.5x focal reducer as well. And I'll show you how that. So this is focused by actually sliding the camera in and out using a friction fit. Sometimes you might need a small piece of tape on the camera itself to get the right friction, but this is how you focus this camera. And it has, John created these nice 3D printed holders. So this allows you to use a 1/2-inch diameter barrel green laser pointer in this part here. If you'd like to use a green laser pointer just to get the camera roughly centered on some bright star so you can begin to star hop, or if you're lucky, the bright star might actually be your pre-point star. This is held onto a tripod using a standard tripod connector here, which is screwed into the bottom. This 3D printed holder actually has an 1.25" by 20" female brass insert in it, so we could attach the tripod connector to that, and then this little tripod here would be the one that you would use. And so in order to assemble this, it'd be pretty simple. We open this lever here, slide our telescope in, typically with the connector handle pointing up to the sky, lock it in place, and this is ready to go. This is so light that it really has no tendency to tip over at all, so probably won't need any counterweights. But if you did want this to be a little more stable on these tripods, you can push this silver button, and then that would allow you to open the legs up another click. And for these small telescopes, this works fine because the back of the scope still won't hit the ground. With the bigger scope that we're going to talk about later, it might get a little close to the ground if the elevation of the star is high. But for these scopes, there's no problem at all opening it up a bit like this. And then this clicks back in place down there. That's the small scope. The mini scope, which is the 80mm Orion short tube 80, looks like this. You got your 80mm primary objective, a focuser back here, a built-in cast dovetail so that you can insert a green laser pointer in a dovetail holder. If you have one of those, that's also useful for just getting initially pointed in the sky. And then you've got focus knobs here as well. And back here, of course, 1.25" adapter. Now, for this telescope, we've got two choices of camera. Originally, I was going to send for this telescope. This is the PC-164 CEX2 that used to be used before we had the RunCam cameras. This is a video camera, traditional NTSC video. It's also got a C-mount to 1 1/4" adapter on it and an 1 1/4" focal reducer as well. So this camera gives a nice wide field of view. It does have some hot pixels in it. These are old cameras. They've taken some cosmic ray hits over the years, I think. But I went through the 6 or 7 cameras that we have here and made sure that I packed the ones that had the least hot pixels, the fewest hot pixels of any. So to assemble this, very simple. Just insert this focal reducer into the back of the telescope. Tighten it up. If you want your stars to drift horizontally across the screen, just point the top of the camera towards Polaris as close as you can, and your drift will be horizontal, which will give you pretty much the most elapsed time possible for the drift. Focusing it is simple like this. There's a focus lock here if you want to use that as well. Pretty forgiving, and this is held in place onto the tripod with 2 pieces of equipment. One is the traditional tripod portable base, and the other one is this little cradle, which is a 1/4 of a 4-inch piece of plumbing pipe, and it's got a hole tapped in it with threads for this screw from the tripod piece. And I've got a couple of pieces of non-slip material in there, so this can't rotate a lot. And so again, to assemble this, it's very similar. We would, I'll turn this around again so it faces away. Open the legs up, tip it back, slide the telescope in, lock the tripod, and now we've got this mounted. Now for low elevations, it'll stay the way it is now. But because of this distance here, this moment arm, if you open this, if you tip this too high, it will have a tendency to tip over. There's 2 solutions for this. One would be to hang a bag of rocks underneath here to keep it more steady. And the other one, which is pretty simple, is just to make sure that one of the legs points out to the back, and so that will minimize the chance of it tipping over. But you can probably get away with opening these legs up 1 click as well, and that will definitely improve the stability. And then you can get pretty high in the sky. I think this should work. I think our star is going to be something like 45 degrees up, so that should work just fine here.
Ted, you didn't mention extending the legs on the tripod. I mean, that's would be another way to get it a little stability, right? Is that, or is that forbidden?
No, you can certainly do that, but I've had the experience when extending the legs that over time, this happened to me at an IOTA conference once, over time, this tripod actually looks pretty good, but the one that I was using, it slipped down slowly over time like this on one of the legs, and so I ended up being pointed away from the star that I wanted. Ooh. 3 hours late. Right. So I typically leave them collapsed. If you find that was a tripod with metal legs and it was very slippery. This is plastic on plastic, which I think has more friction. So it's probably going to work out if you want to extend these legs a bit too. Yeah, no problem. The second choice for cameras, though, for this telescope is something we call the Night Eagle 3. RunCam has begun to market a new camera, the Night Eagle 3. It's tiny. It's just about as sensitive as the Night Eagle 2, but the Night Eagle 2 is no longer being made. So you can see the camera is hiding in there. It's extremely small, and because it runs hot and was very noisy, Bob Anderson came up with the idea of putting a little plate on the back to eliminate the heat. It is also, it has the same connections, which we'll go through in a bit, but unlike the RunCam Night Eagle 2 camera, which is pretty sturdy, the dongle for adjusting the camera's sensitivity is this little guy here. And we haven't really come up with a good way to do strain relief on this. So at the moment, we just have to be really careful not to pull these little wires out. It's possible to disconnect this if for safety, if you want to transport it with this, with the camera disconnected, you can pull out this little connector here. And then there's less chance of actually pulling the wires out of the camera until you get to the site. Then you can pop this guy back in. And David suggested using this camera because it's more sensitive than the PC164 CEX2 camera, and it doesn't have the hot pixel problem at all. So I'm going to be doing some testing tonight if the sky is clear and record some images of a star field with both of these cameras in the same telescope at the same time and see send those out to make sure we're going to be okay with that. Any questions so far?
Just the one I had. That's great.
Okay. All right. Very good. Now we'll move on to computers and the software. So, as I mentioned, this camera outputs both of these, all the cameras that I'll be sending output standard NTSC video, 30 frames a second, 29.97 frames per second. And we'll run the output of that camera through a VTI, the IOTA VTI, before it goes into the laptop for recording. This will place the timestamp on it on the video itself. So let's start with the laptop. I'll be sending 5 laptops. 3 of them look like this. They're new Asus laptops. 2 of them are white Lenovo's. They all work exactly the same way. On these Asus laptops, though, I found that you have to actually hold the power button down for 2 or 3 seconds for it to actually start up. When this little light goes on over here, you'll see that the computer's actually beginning to boot up. And it is designed, it's set up so that it automatically starts IOTA video capture software upon booting. That'll come up in just a few seconds. So let's start, while that's booting up, let's start with the camera and connect things up in the order that the signals will come out. So here's our power supply for the camera here, 12 volts DC. And here is, oh, that's interesting. It looks like this, it's interesting. It looks like the one actually got a defective cable here. I don't know if you can see this, but let's see here. I'm going to have to replace this. See this little piece sticking out here should not be there. That's part of the cable, part of one of the cables that disintegrated apparently and left some metal inside this. So I have to fix that. All right, we'll do the test. We'll do this demonstration here with a. I'll get another piece of these adapters. These are BNC to RCA adapters, and the PC164 camera actually terminates from the factory with a BNC connector, and so we have to leave these little adapters on to convert that output into RCA so we can use traditional RCA cables. Glad I checked that. So here's the output from that camera. We'll go into a cable, and I'll ship 2 cables with each kit. And this video cable will go into the input of the IOTA VTI. Make sure you can read these. There we go. So here's our input for the VTI. And we'll take the other cable take the output from the VTI. And run that into our StarTech video capture device. So this allows the laptop to see the video through this USB connection after we send it in through the yellow input, the yellow video input on the other end. So that'll be the output. So this video should have the image from the sky and the timestamp overlaid on it. And so that USB simply goes into either one of the USB 3 inputs on the computer. Now on the white computers, which you'll see in a minute, the white laptops have a USB 3 connection on the left and a USB 2 connection on the right. And so it's important to use the USB 3 connection for the laptops, the white Lenovo laptops. And those laptops actually have a right angle adapter in that connection, so you'll know which one to use. Use the one with the right angle adapter in it. All right, so this is the IOTA video capture software. Make sure you can see that okay. We'll bring this one a little closer here. So right now it's displaying my image because it's using the internal camera on the laptop. But if we go to the options and select video device, yeah, the 2828 device is not visible because I plugged it in after I started the software. So this is a good example of what can go wrong. I'll terminate the program. And then I'll start it again with double clicking on this little icon over here. It says Capture 2.4. We'll start up again. And now you see it's got a blue screen. It's showing the input, the captured input from the USB connection. I'll just confirm that. Yeah, you can see the 2828 device here is the video capture device, the StarTech device. It shows up as a 2828X device, and it's the default. So now as soon as we power on the VTI and the camera, we should be getting some images here. So we need to put 12 volts into the VTI, and that would be one of these 8 AA battery holders, which will be shipped empty with a DC power plug on it. So we'll plug that in here. And immediately we see the boot screen of the VTI, but there's no video coming into the VTI at the moment yet because we haven't put power to the camera over here. So the next step would be to put power to the camera. Now here we've got several choices. PC 164 cameras require 12 volts. But the run cams, both this run cam 2 that I have here and the run cam 3 that we have here, they will run on any voltage from 5 to 35 volts. But any voltage over 5 volts just gets rejected inside as heat. And so for these, we're recommending that you run these using a 4 battery pack that will give us 6 volts, and that'll keep the camera cooler, and it'll provide less heat rejection, and the image will be better and less noisy. So we're going to plug this in here. Let's see. Okay, I'm using the PC 164 at the moment, so we'll use that. We'll use that camera's output. Let's see here. Here we are. All right, so that camera is now plugged in here, but we haven't put power to it yet. So we'll give this 12 volts with this other 12. We got 2 12-volt packs here. But what you might find is that if you put this camera on a tall tripod, then this might not be enough cable to reach the ground. And so I'm also going to include a little 12-volt extension cable so that you'll have plenty in case you decide to use your own tripod and you want to put this telescope up really high. You can have lots more cable. And then you can definitely lay this battery pack on the ground. So here we are. You can see here we have it's kind of interesting here. We've got, I guess you call it a simulated star field, because these are the hot pixels in the PC164 EX2 camera. This is one of the ones with the fewest hot pixels. So you can see these cameras are probably 10 or 12 years old, and they've developed a bunch of hot pixels. But if your star is drifting across the screen, what you'll just want to do is make sure that it drifts between the hot pixels, so that you don't have that unfortunate coincidence of having the star disappear just as it's near one of the hot pixels. We've already got 4 satellites on the VTI, even though I'm in the garage. So we're actually getting a good timestamp from the GPS satellites. And you'll be all set to schedule your event. Now, there's 2 things that you want to be careful of. One is never to connect these laptops to the internet. They are in airplane mode, and this is very similar to the instructions for the Lucy mission laptops. They run 3 of these run Windows 11, 2 of them run Windows 10, but they are definitely all set up. They've downloaded all their updates, and there's no need to ever connect them to the internet. If you do, who knows what kind of update Microsoft might push down to your computer here, and I can't guarantee anything after that happens. So these are working well. You can start recording anytime by just clicking on this red circle. That would be record, and we'll do that right now. And you can see in the, try to bring this up here. See, it says recording started, and that recording is set up. All these computers are set up so that all recordings will go into this folder called IOTA VC Captures right on the desktop, so they'll be easy to find. These are not touch screens, so you're going to have to stop the recording this way. Clicking on the black square will stop the recording. And you'll notice that the screen goes black for a moment when it starts and stops recording, so don't panic. That's totally normal. It did scare me a little bit the first few times. Now, to actually, I recommend that you use the scheduler that's built in to the software to start and stop, even if you're going to do an attended site. And the way we do that is we click on events up here in the, let's see if we can see this. Oh, there we go. That's a little better. We click on events and then schedule, or schedule if you're in England. And that brings up a menu that allows you to put in all this information. And here you can change the date and time that you want of the event and how long the recording duration will be. The software takes the recording duration, splits it in half, and starts the recording that many minutes before the event time and stops it that many minutes after the event time. So don't put in the start of recording time here. This is actually the time, the predicted date and time of the occultation. And then if you put a 4 here, you'll get 2 minutes of recording before and 2 minutes after. If you put in a 12, you'll get 6 minutes before and 6 minutes after. But of course, it won't take 12 minutes for a star to drift across the field. But if you're on a tracking mount and you'd like to record for 12 minutes, like the Didymos occultations, I think they're asking us to record for 12 minutes because there's a chance of recording a dip in the starlight from the ejecta from the impact. Then you'd have to use tracking, of course, to get such a long recording. But depending on the height of the object in the sky, you'll typically get somewhere between 2 and 3 minutes for the star to drift across this field of view, depending on whether you use the focal reducer. And we recommend you always use the focal reducer. The reason I recommend using this is that you get these other 2 fields here, and you can put the asteroid name in here. And the star in here, KYC, 1, 2, 3, 4. And the reason I recommend that is that when when you schedule this recording and it's started automatically by IOTA video capture, these two character strings will be appended to the file name of the recording, which will have the date and time in it already. So, and it will also include a suffix of the computer ID, at least on these 5 computers, that's actually being used. So you'll know which computer took this data, and you'll know which star and which asteroid and which event it is just from the name of the file. That just, for me, makes it less likely to mix up files with computers and locations and so on. And of course, what you always want to do, if you're using the IOTA VTI, during your recording, you want to flip this switch from time up to position and record on your video the actual latitude and longitude that you're sitting at. And of course, take a second recording of that as well on a laptop, on a smartphone or something with a GPS app, so that you have, individual, you have several backup copies of your actual latitude and longitude and altitude as well, your elevation. And then you can go ahead and record the event. So that's the PC-164 CEX2 image. You can see the hot pixels. I'm going to switch that over now to the, well, actually, I'll leave the camera in here, and we'll switch everything over power. So we'll switch the video input over to this camera, the RunCam Astro. This is the RunCam Astro. Okay, this is the Night Eagle 2. And we'll use the 6-volt power supply instead of the 12-volt power supply for both of these RunCam cameras. So here's the RunCam camera image. And if I take it out of here and stand it on the table to get rid of I guess I have to put my hand over it. There we go. You'll see no hot pixels at all. It's a much cleaner image. Now, in this case, you've got this in the RunCam Night Eagle 2, the control dongle is sturdy and strain relieved. We've been selling these for 5 years now, and they work great. And by pressing this little button in once, you bring up the menu. And by pressing it again, you can change the gain of this by going left and right on this little button. So 9 would be the maximum gain. But if it turns out that your telescope is big enough that you can see the star without all that background noise, you can reduce the gain enough so that you can have a cleaner background. You probably need to leave it at 9. That's the gain. The other option is something called night shutter. And the night shutter option goes from 1 to 3. With 1, there's no integration. So you get the full 30 frames a second. At night shutter 2, it integrates 2 frames or 4 fields into each exposure. So you get 15 frames per second. And with night shutter 3, it integrates 4 frames or 8 fields into each exposure. So you get about 7.5 frames a second. And what we think the case is going to be, based on John Moore's experiments, is that in the small telescope, in the mini telescope with the RunCam, you're going to need NS3, Night Shutter 3, 4 frames of integration in order to see the star reliably. So these are all set up already on NS3 to be able to see that field. For the 80 millimeter telescope, it's likely that you won't need. So originally I was going to send these cameras, the PC-164 cameras, to put in here because they're less sensitive, but here we've got almost 4 times the aperture in terms of square inches. But David suggested using these Night Eagle 3 cameras because they're more sensitive than the PC-164 and they don't have a hot pixel problem. So the kit for the MIDI 80 millimeter camera will include both of these cameras. and you can decide which one you want to use. I recommend starting with the PC one, with the Night Eagle 3. But let me show you what the control menu looks like on the Night Eagle 3. It's a little different than the Night Eagle 2. So I'll put the Night Eagle 3 in here, and we'll take out the power and video cables. We'll plug those in here. Here's our video input from the VTI, and here's our 6-volt power supply. Plug those in, and here's the same image. And again, I'll put my hand over it so it gets dark. So this is the Night Eagle 3 camera image, and when we push the center button to bring up the menu, we get a little different menu. The first line says exposure. That's in it's darkened so that you can see which one it is. If we go down, you go to day or night, color, DNR, image, system, etc. We'll send along a document that Bob Anderson wrote describing the features. But if you press exposure here and then go down 2 clicks to this thing called AGC, or automatic gain control, this will be your brightness control for this. We won't change the brightness option. We'll leave the brightness option on 10, but the AGC you'll be able to change that back and forth from 7 to 8 to 9. And those 3 levels, you see the 9 is quite noisy, but it might be necessary, if the star were really faint. But I'm going to ship these set on 7. But as you can see here on the back, it says the center button to exposure, then click it one more time and set your AGC to 7, 8, or 9, depending upon the faintness of the star. But I'm pretty sure that you'll be able to use 7 or 8 without having to go to 9. There's no integration on these cameras, unfortunately. We haven't been able to get RunCam to modify the software, the firmware inside the cameras to actually do the night shutter 1, 2, 3 options that we have on the older RunCams, which are unfortunately no longer being manufactured. But this is a great little starter camera for folks to get going in occultations. It's tiny, it's light, and eventually we'll come up with a solution for strain relief on this little cable here for the control. You can actually feel with my thumb the heat coming out of the heat sink. So this is really doing a good job of keeping the electronics cooler than they otherwise would be. And I've got a drop of thermal paste in between the heatsink and the back of the circuit board that basically makes up the entire camera. And then I've just wrapped a zip tie around it so that we get a little bit of little strain relief, at least for the main data and power cable. But we can't do anything yet about strain relief for the dongle for controlling exposure. All right, so we'll return and then go up 1 and click on exit. This camera, I'll point this out, this is kind of important. The Night Eagle 3 camera saves your settings automatically, no matter what you change it to. So even if you power it off and power it on, if you set this to AGC 8, it will be at AGC 8 when you start up again the camera after powering it down. That's not true for the Night Eagle 2 camera. Night Eagle 2 camera, when you have 2 choices when you exit the firmware exposure menu, exit or save and exit. And so if you've decided that Night Shutter 2 is sufficient and you're going to change that from Night Shutter 3, make sure you save when you exit so that next time you power up the camera, it doesn't go back to Night Shutter 3 again. That's only true for the larger orange RunCam 2 cameras, that it has the ability for you to choose whether or not to save your changes. On the smaller Night Eagle 3 camera, changes are automatically saved and there's no option. Whatever they're set at when you exit are the settings that will be retained next time you power up the camera. And for the PC-164 cameras, there are no internal settings at all. There's nothing you have to worry about. And these switches on the back are irrelevant. So this camera, you just plug it in and that's what you get is what you get. The only way to change its sensitivity is to put it into a larger telescope. So if we set this, let's go back to the software for a moment here. Let's set our, get this lined up so you can see. There we go. So I'll set this for, let's say 5 minutes from now. You can just type the numbers in, or you can use the up and down arrow buttons on the keyboard to change these times. So 30, 31, 32, 33, 34, 35. Set this for 16:45. And of course, these computers are all set on UTC time and UTC date. So I'll click on schedule. And now you can see that another box pops up and it says countdown to recording start time. This will start recording in 50 seconds. So if you've got the camera or the computer accurately set something within a few seconds of UTC, then the time that it starts the recording will be 2 minutes before the event or however many minutes you have. And then once it starts recording, it will count down to the event time as you watch stars drift across the screen. And then you'll get, it'll change to countdown to recording end time. You'll see 2 more minutes of recording and then it will automatically stop the recording. And again, it's placing the recordings here into this IOTA VC capture folder on top of the desktop. We'll watch the recording start. There we go. It blinks to black when it starts the recording. And now we've got countdown to event. We'll have the 2 minutes there. And then the event time will pass. You imagine stars are drifting across the screen here. Eventually your target star will come into play, drift across the screen, hopefully be somewhere near the middle when the event happens. And then it'll go off the screen and you'll get about 2 more minutes of recording after that. So this will stop automatically, but I'll stop it now just manually by clicking on the little black square. And it'll say, hey, there's an event recording in progress. Are you sure you want to stop this recording? So we'll say yes, just for fun here. There we go. So if we double click on this little folder over here, bring up a Windows folder. Here's the quick manual recording that I made earlier. You can see all it has in its file name is the year, month, day, hour, minute, second. But over here, the one that we did with the scheduler has all that information and the name of the asteroid and the name of the star and the suffix of the computer name that did the recording. So all those things are useful, I think, to have yourself less confusion over which is the data, especially after we all upload our data to some common server and they all get mixed up. This will help keep them separate. I think that's about all I have to offer today, but you guys probably have some questions, so feel free to fire away.
Yeah, I got a straightforward one. So the computer clock tends to drift. So it's our job to set the clock on the night of the event to make sure it's correct, or are these clocks better?
Yeah, I usually try to set it, in the afternoon of the event day.
Okay.
But it will only drift a few seconds during that time between the afternoon of the event and the event. And a few seconds doesn't matter in terms of when will this recording actually start, because it's a 4-minute recording by default, at least. So a couple seconds either way on the start time won't matter. But if you leave one of these in storage for 6 months and then take it out, you might find that the clock is so far off that it will start, it'll start your recording the day after the event. And that would be a disaster. So I just make sure that they're fully charged and that the computer clock is set to the proper UTC, which I usually get from time.gov or from an app, like an app on the phone that'll give you UTC time. Again, just sometime during the day of the event is plenty soon enough for that.
And then as far as battery lifetimes are concerned, between the AA's and the computer battery itself, you know, how much time is on the clock when you set one of these up and walk away?
Good question. The laptop batteries I've tested for 4 hours, and the new computers actually went for 7. The Asus computers. For the cameras, the VTI, that'll run for 12 hours on 8 AA's.
Okay.
I'm not sure about running the small camera on 4 of these. I'm actually going to put together 2. I have these little 4 battery packs. I'm going to put 2 of these back to back and wire them up specially so that it's 6 volts, but with double the watt hours you would have from just 4 batteries.
Got it. Yeah,
And
makes sense.
they'll be labeled as 6 volt only to be used for RunCam cameras. But that would guarantee you that the RunCam camera batteries, these 4, would not run out before your event.
And when you say the laptops last for however long, you turn down the screen brightness, effectively turn it off when you walk away from the site after setting one up?
Thank you. Good question. The laptops are set up with every possible background task killed, including Microsoft Defender. There's nothing running on here as far as I can force it to, except the IOTA video capture program. And they are set up so that when you close the lid, they do nothing except shut off the screen, which happens from a mechanical switch inside. So when I do this, that's the way I leave the camera. If I'm leaving one of these behind, for many reasons, obviously we don't want them stolen either. But when you close this, even if you're doing an attended observation, closing the lid will cut off the battery power being used to light up the screen, unless you have an inverter and you power this with the included charger, and you like to sit there and watch stars go by just to double check your pre-point, which I do a lot. You can of course leave it open. Occasionally I have seen a situation where closing and opening the lid will cause the IOTA video capture program to freeze. There's some unpleasant interaction between Windows and the lid open and close software. And if that happens, then you could just, anytime you want, just stop this program and restart it by double clicking on Capture 2.4. And that'll bring it back up again.
Will it remember the most recent parameters you typed in as far as time and asteroid name and all that? Or
yes, everything. Oh, yes. The event, when you there's no event scheduled at the moment, but it stores the scheduled events in an XML file, and so it reads them upon startup, and they come, that little display showing how many minutes there are till the beginning of recording will pop right up again. Yeah, it's very well written program. I really love it. All the other options have already been set, like to make sure you use the Lagarith codec to compress, losslessly compress the video. The duration default is set for 4 minutes, but again, you can change that if you want to. And there aren't any, you won't have to do anything to the software other than schedule an event using events, schedule. And of course, if you schedule an event incorrectly, there's also events, edit and delete, and that'll bring up a menu with all of your scheduled events, and you can go through them and delete them. If you've scheduled it wrong, you can delete it and start over and do a new event.
And you have questions?
Probably a dumb one. How long does it take the stars to drift across the screen?
That'll depend upon the focal length of your telescope. For this little guy here with the widest field of view, it could be 4 to 5 minutes of drift time. Again, if
But
the star
that's
is
how long
low
your
in the-
recording is, right?
yeah, exactly. But
Yeah.
your 4-minute recording will your stars will drift very slowly across the screen if the star is low in the sky and you're using this particular telescope.
Mhm.
With the 80 millimeter scope, so this will be f2, like f1.5 or something after the focal reducer's in it. This is an f5 scope and it'll be f2.5 with the focal reducer in it. So instead of f1.5, you might get, in the same location in the sky, you might get 3 minutes drift time or 2.5 here versus 4 or 5 in this scope. But
Okay.
regardless of that, the even if you record for 10 minutes, you're just going to get a whole bunch of stars that are nowhere near the target star recorded at the beginning and at the end. And the only thing that matters, of course, is that the star field, including the target stars, somewhere in the middle of the screen at somewhere near the occultation time for a pre-pointed telescope. If you're tracking on a tracking mount, some people in Spain might have tracking mounts, then that completely changes, and you can it's up to you to continually tweak your telescope parameters to keep the target star near the center of the screen. You don't want to go in for coffee and come back and find that you've drifted off the field and now you can't find it.
Mhm.
But if you're using pre-point, you don't have to worry about any of that. As long as nobody kicks the telescope, you'll be guaranteed to have the target star drifting somewhere near the field, near the center of the field of view at somewhere near the time of the event.
So I think that raises the question you probably don't address here, but the finer points of pre-pointing, especially for multiple systems. So, for most of these events, there's a very obvious, pre-point field or star that you can go to. But now when you're talking about setting up 3 systems, you basically need 3 pre-points or some strategy for dealing with that. And I don't know if you have guidance along those lines, or if we, at some point should have a separate conversation. But I'd be curious. I've been using plate salt to pre-point, which takes the fields out of the equation. You just point to coordinate essentially. But I've been doing that with one telescope, and this will be the first time I've tried to set up more than one, in addition to my own. So my plan is to take 2 of these systems myself, and then I've got a system of my own with me. And I think that's going to fill my plate for this event, just because I'm not terribly experienced. But anyway, pre-pointing multiple systems.
I agree. I think 2 is the most I would try. And if the first one is takes a long time to do, I would spend the time on the first one to make sure that you allowed it to drift far enough that you could see other stars go by at the right time. But let me do something here. I'm going to try to share my screen, my desktop, do a real quick demo of how to come up with pre-point maps of the sky using guide. Just minimize this guy here. Oh, okay, that guy goes down there. Got all kinds of files open here. We don't need those. All right, good. Get rid of that. So what I'll do here is I'm going to share my screen, the whole desktop here. Where is that? Share the screen. Oh, it looks like the entire desktop. Okay, good. There we go. All right, so here's my desktop.
Got it.
I'll bring up Occult Watcher, and I'll go down to some star, some event coming up in the future here, a fairly bright event. Let's see here. All right, and it's a 12.8. All right, so here's Latona. So this is just a shortcut to get guide open.
Mhm.
If I right click on this and click on show event in guide,
Mhm.
it'll bring up guide, and this target star will be centered on the screen.
Mhm.
Zoom in on that a little bit here with the star button. There's our target star. So if I right click on the target star, this is important to right click on it and make sure you've got the right star. Let's see here, 16, 15.8, 16, and 9. Well, that we're supposed to have a 12.8 star. Let me pick a different event here. Let's see here. All right, here's one with this got a 9.9. So I'll right click on this and say show this event in guide. And what it does is it okay, so there's our bright star. It automatically centers that star, and it sets the time and date to the time and date of the event. So at this point, the asteroid should be right in front of that star. And if I turn on asteroids there, turn on asteroids. Well, it's not showing the asteroid there, but anyway, that's the SAO number of the brighter star. So what we do is right click on this star, confirm that it's the star that's supposed to actually be, this is 385, 160, 645. Yep, there it is down here in the corner. And we right click on that. And, oh, sorry. Once we right click on it to make it the selected star, we go up here to animation and say add a trail. And there's a presentation by Scotty Degenhart on the on how to do pre-points, but these are the settings that we use. -1 minute for the step size, checkbox, all these boxes, index frequency set to 1, time label frequency set to 1, and then how many steps, or in this case, minutes, do you want to go back? So let's say it's 4 hours. 4 hours would be enough. So that would be 300, that would be 240 minutes. So we say we want 240 minutes and click on add a trail. And now let me move this over a little bit. Right now, this timeline has appeared on the screen. And if we zoom out with the slash button, you can see all those times represent. Let me turn off asteroids.
A lot of asteroids. That's really nice. I like this.
Yeah, this really, really helps a lot. All right, off with the asteroids. There we go. So now the way guide works is wherever you click, left click, that becomes the new center of the screen. So it doesn't use the arrows. So if I click here, that becomes 551 becomes the new center of the display. So the way to move to the right is to keep clicking somewhere over here near the right. And depending upon your field of view, let's say under settings, we can say, oh, sorry, display a CCD frame. They ask you for the focal length. So in the case of the 80 millimeter scope, the focal length will be 500 millimeters divided by 2, so 250. And actually, I found out that you put in a number about 20% less than that. This is too small. So we'll put in 200 for a focal length of 250 millimeters. And that rectangle will give you approximately your field of view on the camera screen in the IOTA video capture window. So now if we go to the right here, and again, we can zoom out and see more sky and look for a bright star somewhere that we'll be able to find. Like, okay, so here's I'll zoom in a little bit here. So here's star Algety star that should be easy to find with a pair of binoculars. If you bring that star here, and then you'll be able to see. Well, let's see. So how bright is this guy here? That's 9.3. So that's already brighter than the target star. for Eurbybates. So if you were to center this, then this would say put these two stars in the upper right corner at 3, and if you right click on the line, it gives you the time on that trail. So at 3:25:50 UT, if this is what your picture looks like at 3:25:50, then the target star will be right at that exact spot at 6:04:37, which is the target time for this particular event. And then if you go to your next, so bring along a laptop with guide installed on it, or print out all these pages and bring them with you. I've gone, David is creating the pre-point charts for this event, and he's going to create a PDF file with dozens and dozens of these. Bring that along with you, of course, on your laptop. But I also like installing guide so that I can check any time. So if I did that, and then 5 minutes later, I looked at the screen and it looked exactly like this at 3:57:50, I would say my pre-point is perfect. I can close up shop and move on to the next event, next site.
Yeah, and I'll make sure this is installed on the computers we'll be using.
Yeah, and make sure that the UCAC4 catalog is also available and visible, because otherwise it's hard to put the I've got it installed here. So do you remember the sorry, they've given us a TYC object name for the target star in this case.
Yeah.
So guide star. So, but you can put that in here as well. TYC, I forget dash. Let's see if that shows up. Not a valid object. Yeah, I didn't think so. But for UCAC4, the secret code is 4UC, then the 3-digit prefix dash, oops. Oh, that's my phone. Excuse me. Just shut that off for a moment. Okay. More spam. And then the 6-digit star ID. And that will bring you directly to the star. Yeah, in this case, obviously not a valid object. But that's how you enter a UCAC4 star name versus a TYC star name, a Tycho star name. So I like bringing along a working copy of guide on a laptop. I bring it along with me. I bring along a little box that I can put my expensive fancy laptop on so I don't get dirt in the keyboard. That's happened. The laptop you use for data collection, you can just put that in a bag of some kind, or wrap it in a towel or whatever to keep it clean. But I bring my home laptop with me, and I have done the dirty deed of mistakenly kicking a whole shoe full of dirt into the keyboard. That's really annoying. So be careful about that. But yeah, out in the field, if you have just 2 sites, just bring it along and be careful. And don't forget to take your green laser pointer out of the holder and bring it to the second site. If you only have one, that's the easiest mistake to make, is to leave your green laser pointer behind at the previous site, still attached to your telescope.
And we would have to bring our own. That's not in the kits.
That's not in the kits, right? You'd have
Got
to put your own.
That's a 1/2-inch diameter barrel.
1/2-inch diameter barrel would fit or actually it's 3/4-inch diameter barrel. Sorry. It's a standard, like Chinese big laser size. That the ones that you can get on Amazon, they're 3/4-inch diameter. But okay, so let me stop sharing here. Go back to the camera for a minute. There's our camera. Okay. Yeah, if you're gonna try to put a laser pointer in here, let me go grab the little kit that I have in the house here. 1 second. All right. So you have several choices. What I use on the midis is this little kit here. It's a bracket that has a Orion dovetail on it, and there we are. Orion dovetail on it, and it's adjustable to hold a half-inch diameter, small size green laser pointer, and it has this little screw on it, so you can turn this on, and it'll keep the laser pointed on, and then you can slide that in here, and it's pretty easy to see the green laser dot on the computer screen here if they're lined up. And once they're lined up, then as you move the telescope around, the laser dot stays in the middle of the screen, but the stars move as you go and find your new pre-point location. So this is what you want to remember to take off when you go to your second site. The other, if you have a 3/4 inch laser for the MIDI camera, you can get one of these from Scope Stuff, and this will hold the 3/4 inch laser and also make it adjustable, and this will go into the Vixen dovetail. Or absent all that, you can just use a regular red dot point finder and use that to roughly align the scope on your pre-point star, or the first star you're going to use before you hop to the pre-point star. So lots of choices there, but I always like using this so I can look up into the sky and, you know, be sure that if I'm pointing at Arcturus, just to be sure it's actually pointing at Arcturus and not a bright star nearby, because you're all in the business. You know that all the stars look alike when they're in a telescope.
That's great. Thanks.
Okay. Well, I noticed that this laptop has been in the case, just sitting there shut off for like 2 days, and the battery is down to 20. When I opened it, it was already down to 20%. So I'm concerned about that. I'm going to go check the other two and make sure they haven't lost power. Maybe this one was asleep instead of completely shut off, but I know I shut them all off. So I'll double check that right now. That doesn't happen with the two. I'll bring one of these other ones out for you. This is the Lenovo model. And you can see that it has a little right angle adapter on it for the USB port. This is so that when I put this into the plastic box that I use for dust control, if I don't have this, then when the cable sticks out sideways, it's too wide to fit into the box. So again, this is very similar to the Asus laptops. But I bought the Asus laptops because they have new batteries. These batteries are at least 10 years old. And I've tried to put new batteries in, and it will not accept the new battery. The BIOS won't even accept the new battery. But the chargers for these are also included. So just keep them all charged up, just like we do on events for Lucy mission with Mark. Okay. Any other questions? Send me an email. We'll answer them. But that should get you going pretty well. And I'll put this recording up on YouTube so everybody can watch it in advance before you all get to Spain.
Sounds great. Thank you so much. This is just fantastic and extremely helpful. So
good. Well, I know that all this
Ditto for me. Thanks.
was new to you. So yeah, definitely worth a little bit of explanation in advance. Okay, good luck over there. And I'll be sending this off to Ann probably tomorrow. I do want to get a couple of images of the sky in these two cameras with the 2 different telescopes and with the 3 different cameras, so that we just kind of get an idea of what the limiting magnitude would be for each of them, and what settings you might need, whether you can get by with AGC 7 or 8 or 9 on this Night Eagle 3, or Night Shutter 3 or 2 on the Night Eagle 2 camera. Okay.
got it. All
Very
right.
good.
Well, thank
Thanks,
you.
guys.
All right. See you.
Best of luck.
We'll need it.
I know. Okay, bye-bye.
See you.